Okay, we'll get started. A couple of people feeding in, but yeah, let's get started. So welcome everybody. Welcome to the last session of the day. I hope everyone's had a good day. Seems to be pretty action-packed, especially with quarter an hour in between, everyone rushing around. So hopefully you've had a first good day. Looking forward to tomorrow. My name's Mark Scurrell. I'm a program manager on the Azure team. I'm in the product group based in Redmond, just outside Seattle. And I work on the overall Azure Compute team. And we basically got the responsibility for pretty much all of the compute stack. Certainly what we refer to as infrastructure as a service and a lot of the platform as a service offerings. So I gave a talk a couple of hours ago about IaaS and getting started with Azure. So our team covers defining the hardware roadmap, rolling out the new hardware, exposing that via VMs, exposing that via higher level capabilities like scale sets, container service we'll discuss here briefly, batch, and so on. So yeah, in particular, I work on the what we call sort of like the big compute team. My sort of main focus day to day is large scale compute workloads, and often I sort of talk to people who really do leverage the scale and elasticity of Azure. You may be deploying 5,000 cores for a few hours and scaling back down again. So pretty interesting and it's been pretty fun probably over the last 4 years seeing how the move to the cloud and how Azure has developed. So in this session, we're going to basically cover about maybe 90% of this session. We'll cover sort of microservices, and it'll be very much focused on then sort of implementing some microservices with Service Fabric and really that introduction. Now I'm going to just give a very short sort of overview, sort of brief demo of setting up ACS, Azure Container Service. But really I'm not going to go into any sort of detail there. And sort of really the main reason is there's a lot to cover even to sort of provide an overview of the microservices and Service Fabric. And then there is tomorrow, a really deep dive into the container service. So just if you're coming along and you want that more detail on ACS, I don't want you to be disappointed with the session. We'll cover it for about 10 minutes at the end, but the majority of this talk will be on microservices and Service Fabric. And check out the session tomorrow at 1:45. A colleague of mine is giving that. So let's get started, and it's sort of interesting because I was sort of involved in, before I joined the main Azure team, I was on the SQL side, SQL Server side, worked on, I think it was SQL Server 2008 and 2008 R2, and I was involved in the move of SQL to the cloud, and what we used to call SQL Azure and is now Azure SQL Database. So if we go back, I mean, it's maybe 5, 6, 7 years, we sort of had this challenge with SQL and actually a number of our other products that we want to sort of take these existing on-premises applications, sort of developed in a certain way, deployed in a certain way, managed in a certain way, and create basically the cloud versions of these. And there's sort of pretty interesting sort of things we had to consider and take into account that sort of really sort of influence then, we need to build up some platform and capabilities to sort of really cater for the differences between on-premises based applications and cloud-based applications. Whether writing them from scratch or you move, or effectively, in our case, we were moving or sort of effectively porting a code base so it ran in the cloud. So there's a bunch that are maybe sort of obvious here. Obviously we don't own the hardware anymore. Even when I was working on SQL Server, we used to have, initially there was sort of big, almost like mini data center rooms within our building, and we had a bunch of servers there. There was sort of data centers sort of fairly nearby for some of the workloads. But now with the cloud, I mean, literally we're sort of deploying this. We've got our 36 regions we heard this morning. Around the world, and we're nowhere near this hardware, so we can't even sort of just even drive down the road or the freeway to go and see if there's an issue. The hardware, again, I'll draw some analogies from SQL. The hardware is pretty different. In the SQL world, we were used to, you're rolling out really hardened production SQL Server and capabilities built on that, and you've got high-end hardware, very reliable, SCSI drives, blah, blah, blah. And very expensive, but very reliable because you've got that sort of set of hardware. And then we're sort of moving to the data center where we've got clusters and clusters, or even hundreds of clusters in there. Obviously, a lot of the time it's sort of commodity hardware. It's almost like, the Azure and the cloud, we build it like we expect failure. We know B pieces are going to fail. And part of our challenge and actually our job is so that you don't get impacted by that. But, we have to deal with that. Hard drives failing, motherboards failing, network switches dying, that sort of thing. So a lot of what we do in our platform is be able to sort of cater for those failures, hide them, certainly recover from them, and so on. All the while, certainly with all the servers that we have within a region, sort of ensuring we don't have to have hundreds and hundreds of people managing them as well. But in terms of developing the software, we had this very different type of software. Actually, there's a whole bunch of. Remember the time, it was, well, look, we go into these machines here, and they've just got IDE drives, and for all the reliability, SQL, you need to be running on SCSI drives. Scale's pretty interesting, and can be predictable or unpredictable. Can be predictable, but you certainly, how do you scale? How do you ramp up with increased usage, or even sort of cater for sort of decreased usage at sort of times of the year? How do you cater for peaks like holiday season or Thanksgiving, without and still be efficient and buying a lot of stuff that you don't really need. So sort of we have to be able to scale our services and scale the software that we're writing. I think managing them is definitely a challenge as well. I had a lot of learnings around managing this. Yes, it's far away. Yes, there's thousands and thousands of these servers, and we've got tons of people using these things. And it's not just like you're scoped. You got maybe your SQL Server deployment, and you got to manage those 2 or 3 machines or 10 machines or so on. We literally have thousands and thousands of effectively servers. To monitor and manage and ensure they're healthy and so on. And, one of the big learnings there, and I think actually Jason referenced it this morning, and we sort of highlighted some of the capabilities we're making available to you guys. But for us is like, I think he said it was literally in the petabytes per day of data sort of we generate from all the sort of telemetry that we have. And we basically need to be able to, monitor that and not have it so it's so noisy that we're getting interrupted with false alarms, but know when, there's something that needs some corrective action. So the monitoring, having the telemetry, having the tools built over that telemetry has been, definite challenge and consideration for moving to the cloud. You don't get any downtime, obviously. You have to upgrade on the fly. There's no sort of taking stuff down. Hey, look, it's at midnight, between midnight and 5 a.m., there won't be a service. That just not possible anymore. Costs, managing, are you efficiently using that hardware? Are you packing stuff appropriately? Or are your CPUs sitting there at, an average of 3% utilization? Are you making the most of what you've got? And obviously, sort of virtualization, and now with microservices, you sort of really, with those sort of technologies, you're sort of really able to sort of pack things more tightly and be more efficient. That was the costs. Obviously, security, talked about, Jason covered that quite a bit, and caring about that. And then, in terms of building these applications, what's your developer productivity going to be like? You're going to have to, going to talk tomorrow, and we sort of talk about the expectations from our customers, and sure some of your customers sort of are changing in terms of like the frequency of updates and new features appearing and new capabilities appearing, and we're sort of rolling out. I think over the last few years, those that have been following Azure or using the capabilities, we're sort of down when on actually the particular service I work on. I mean, literally in a week, we can be rolling out anywhere from 1 to 3 updates to that service. Maybe every few weeks there's some big new piece of functionality or whatever. In Office, I think a great example these days is Office 365. Like how frequently you're notified, hey, there's a new version, and you get a whole bunch new functionality there. So, how does the developer cater for that? You need a developer platform sort of to cater for the cloud and ensure your developers are being productive as well. So I think I sort of touched on some of this, but this is where the microservices approach effectively came from. It was sort of really to satisfy these sort of particular set of requirements or characteristics of the cloud applications. Your applications continually evolving, continually being updated while maintaining that uptime, for example. Those customers expecting those fixes, very, very quickly, or the new features very quickly. And then obviously being able to operate at scale. So, sort of this sort of cycle there, hey, doing your development, planning, doing your development, testing it, releasing it. Monitor, is everything okay? Is it going as expected? If it isn't, you've been able to cater for that. And then you're going around again. It's sort of actually just sort of thinking about it again. I suppose from the development standpoint, one of the interesting things is I sort of find interesting looking back on it is we used to get these, Microsoft, we used to get these ship it, like sort of rewards, but you get a little plaque, hey, I shipped this version, this version of SQL Server 2008 R2, and maybe every 1 year, 2 years, you'd get this. And let's just say in the cloud world, we don't get these anymore because we're literally releasing every week or even every few days. And it's almost like even the concept of any sort of big release in a lot of ways has even gone away because it's a lot more incremental and fast. So it's sort of funny to think how things have been changing over even the last few years. So in terms of methodologies, certainly I sort of go back when I was sort of developing in early days at Microsoft as well. You sort of have your sort of more traditional sort of three-tier approach very frequently, sort of client server, some sort of back-end store, persistent store, database, some sort of like middle tier, and then your front ends, and you deploy your appropriate pieces of the application sort of across those tiers. So in that sort of contrast to sort of the microservices world where you really just get a set of machines, and really, we call it a cluster in Service Fabric. You're basically just getting a cluster of machines. You're going to link them up, obviously, so that they can communicate. And then depending on the services that you're sort of deploying, you can just deploy your services, and effectively the services, depending on the requirements and the scale, and how tightly you can pack and so on, you can spread them out across, across that cluster. So when we build these sort of more sort of traditional application, it's sort of interesting in terms of again, you sort of build them and, that contract. Where do all the pieces sort of tie together? Where's that contract defined in terms of this layer talking to this layer, talking to this layer? And it sort of can be thought of, it's definitely more of a, and definitely some of these layers, more of a compile time contract. You're sort of compiling this up, you're sort of building everything and then deploying the XCs or the DLLs or the various components. So it's all sort of local operations, sort of easier to think about, but when it comes to sort of being more dynamic in terms of the scale, and certainly when it comes to sort of the cloud scale, it can be really expensive to scale and hard to scale that appropriately. And this was sort of really a challenge that we had. We'll go through a few of the products, but obviously, it's the way we built the products, and we had to change moving forward and moving some of those products to the cloud. So really, that previous diagram sort of becomes this, where you have the nodes and then sort of various of these sort of microservices or these sort of components that are deployed. And so really the contract, it's more like they're talking over the network or talking sort of via RPC, and more of a runtime contract as opposed to a compile time contract. And then hopefully we can scale that more cheaply by, we can add in nodes, or if a node can be more tightly packed, we can add more instances, for example, for the front ends, without sort of changing the rest of the things or recompiling. And even when parts of the components change, we can update them or upgrade them independently. So when we sort of start moving to this architecture and sort of design pattern, it sort of starts to get cheaper to scale and easier to scale the access, and then sort of the upgrades as well. I've got a demonstration later on where we go through upgrades, and sort of upgrade can be more sort of continuously. So state is something that we definitely want to sort of highlight when it comes to Service Fabric. And, more of the, again, approach with sort of databases and obviously SQL Server, or more recently like the NoSQL stores, DocumentDB, or, any of the other like NoSQL stores. You're going to have your application, and then, maybe it's one. I mean, it could be multiple. But you pretty much have these databases where you're going to store your state. And then, I certainly know from experience, depending on the application, you're going to end up with hotspots there. You're going to end up with, hey, some tables are accessed more frequently than others, and you have to work out how to sort of scale that. Or you have to sort of partition your data so that, hey, look, there's more frequent data that's accessed very frequently, very often, updated, read very often. And then there's some older data, maybe the stuff from last month or last year, it still needs to be there, but isn't accessed as often. So, you sort of really get some interesting challenges in sort of scaling out the, the storage and sort of your persistence layer there. And one of the things that, with microservices is supported by Service Fabric is sort of that ability. It's got effectively a built-in storage technology as well. So you can have these stateful services, and effectively the fabric itself, the microservices themselves, with the framework that we provide, offer you some storage capabilities that mean the data can be stored effectively without a monolithic one big sort of store, and easily allows you it can spread out or effectively partition that data across multiple nodes, use the local storage on the nodes. You can scale it out when demand increases, or scale it back down. And then it's also resilient to failures and node failures. Obviously very important. If you're storing the data there on the node and then something happens to the node, you can't lose your data. So certainly with Service Fabric, and we'll see a demo of this, we have something called a stateful service, where you can actually use Service Fabric, and it offers some storage, basically first-class storage capabilities for your application. But it isn't I think one thing to highlight there, it isn't like an all or nothing. Again, we'll sort of hopefully reinforce this, but you can certainly start off, you can use Service Fabric, and you can use microservices effectively with your existing database. I think this was what Lync at the time, now Skype, did when they moved to the cloud, was they basically took some of the data, certainly the very high scale, very hot, frequently updated, frequently read data, that sort of part of the data, and moved that and started using the stateful services and that technology, and had a hybrid. And then maybe over time, some more moved to Service Fabric, and then it was perfectly fine for some of it could remain in that database. So it's definitely not an all or nothing. And in general, the move to Service Fabric, what we'll see is, you can start off even just like bringing your XC or bring your ASP.NET app and so on, and then you get some benefits there, and then as you invest more in the maybe the frameworks and developing these specific services, stateless services, you'll get more and more of the benefits. So it's definitely not an all or nothing, and you have to jump in a big thing. You can get there gradually. So just to reinforce some of the benefits there of sort of splitting the application up into these sort of separate components. Covered some of these very briefly, but sort of scale definitely is one of them. If we've got a sharing service and a thumbnail service, but you need to generate a lot more thumbnails, or for whatever reason the algorithm you're switching from a simple algorithm maybe to more of a use some learning and do a cleverer sort of thumbnail, then you might need to sort of scale that out and be able to do that independently without impacting, upgrading, or taking down the rest of the some of the other parts of the service. Different technology stacks, definitely possible. Obviously, they're independent pieces of code. You could develop them with different pieces of technology. Could be legacy components that you need to use with sort of .NET, and maybe in the new stuff you're using Node.js, for example. Version them independently. We'll see this actually coming up in a few minutes. Version them. Have the other one there. You don't need to upgrade that, but just independently update to V2 for the thumbnail service. And then there's a little bit of maybe an edge case, but sort of an interesting one is basically when you've got the shared dependencies, and that you could, you could update the dependency, that needs to be a newer version is required by one of these microservices and not the other. So we could have the thumbnail service then use this shared library. So some of the benefits. But what we'll see is, or if you sort of take into account that, well, I've got this cluster, it could be any number of nodes, I could have effectively multiple applications I'm going to deploy to these, each with different services or microservices, some of them stateful, stateless, nodes can come and go, I need to upgrade. It's like, yeah, this is all great, but I need to cater for, now sort of provide the sort of capabilities around the service discovery. I need the built-in, the state management. I sort of need to be able to track, well, what state are my apps and even these services in terms of, are they there healthy? Are they unhealthy? Are they being upgraded? Have they finished their upgrade? If effectively you've got this big cluster with many apps in it and many parts of those apps, there's quite a lot to, you're going to need to keep track of and manage the health, and know what resources are being used, maybe how well they're being used, and so on. So sort of these become the requirements. That's almost like the fallout. Well, this is great, but then that means we need some of these sort of these capabilities, or need to cater for these sort of these cases. So that's really where the platform comes in. You sort of really need a microservices platform, both design and there we go. So sort of design and build, your microservices, have the platform for that, then as well as, and sort of cater for build the applications, build many applications, and provide the flexibility around language and frameworks and so on. And then once you've built them, be able to roll them out, maintain them, upgrade them, know that they're healthy, and monitor and manage them. So they sort of really become sort of the main requirements. And this is really where Service Fabric, or really what Service Fabric was built for. Oops, let me go back there. So really sort of cater for, we'll go into a bit more detail soon, and cater for building those microservices, and then providing that platform so you can actually deploy them, everything from the lifecycle management to the auto-scaling and the tooling and so on. And then I think sort of a key thing with Service Fabric is sort of the ability, we've got both Linux and Windows there, that sort of really talks to sort of the flexibility and choice around even effectively OS, as well as sort of frameworks and apps you want to run. But then where you deploy it. I think sort of particular strength is, I'll be doing some demos, I'll just be doing my dev box, effectively we've got a local dev cluster there that you can deploy to Azure, have a whole bunch of nodes, maybe have some massive scale in Azure using either Azure VMs or containers on Azure VMs. But also be able to deploy it on premises as well, or effectively private cloud, or even other clouds. I think there actually is an example of Service Fabric being used, and then the application ended up getting deployed on AWS. So it's sort of really providing this platform. So I put this in, sort of went through and sort of trawled like some of the internal services or internal products that effectively use or powered by Service Fabric. I talked about SQL Database, and that was probably one of the first ones to that really led to the evolution and the production of Service Fabric. But you can see here a whole bunch of other services, a lot of even the more recent ones around IoT Hub, Event Hubs, and so on. And all of these, they're all huge scale applications. Obviously, all have a lot of state and so on. All running effectively on Azure and all built with Service Fabric. So let's go into a demo. Really, what I want to do is, after that introduction, we sort of talked a little bit about the microservices and the difference, and then I'm going to jump into these sort of demos and go through some. They're almost like Hello World demos. This is a pretty deep area in terms of Service Fabric. So really, sort of just my goals here are sort of just to give you that flavor, sort of give you the flavor on the background there, and then the why, and then sort of give you a flavor of Service Fabric. But it's sort of going to keep it fairly simple, just to get so you're familiar with some of the concepts. And then if this is of interest to you, you can go away and dig deeper. And there's some links and stuff at the end. But we could probably have even a full day or so on Service Fabric sessions to really do a deep dive for you. All right. So we're going to do a stateless service. All right, that's up. I'll do my best here to, I know it's small, I'll set the font up and I'll do my best to use Zoom it as well, so to cater for folks at the back. So actually what I'm going to show you, effectively is the hello world of stateless services. And it's really actually a really nice examples, literally just built in and very illustrative into the initial templates. So I'm VS here, and you can see in the templates, I'm going to use C#, and then cloud, and then in here, obviously, we've got some of the other, Azure capabilities, web jobs, mobile apps, and so on. And then here we've got Service Fabric. So I'm going to pick that. Now we're going to touch on all these sort of a little bit, but probably really mainly sort of these two, stateless and stateful. So stateless is maybe where you're developing something that literally doesn't have any state, completely stateless, or the component itself is stateless, but it's working with like an external database or NoSQL store or something like that. So we'll touch on that, and then next we'll move on to the stateful. So this is literally going to build up a stateless sort of microservice, and it's pretty simple, but it is pretty illustrative in terms of all it's going to basically do is count. And so we have iterations here, starts off at 0, and then we're going to count, we're going plus iterations here, and it's basically going to count, and it's just going to go around in an infinite loop and count. So just to, hopefully we can sort of see here. So this is sort of starting to use obviously we're in Visual Studio, we're sort of in the development phase, and sort of this is sort of almost like the introduction to some of the sort of the frameworks that we're providing and the programming models we're sort of providing to produce these, these microservices. So there's what have we got? Sort of listeners. And then there's sort of this run async, and just again for this super simple example, we've got just literally everything in here. Iterations is to 0, and just forever go through and increment that. So before I run that, what am I actually going to run it or deploy it to? And I sort of talked about the flexibility from being able to go from anything from a local, even on my laptop here, like a local cluster, all the way up to maybe thousands of nodes thousands of VMs in Azure, or and then maybe somewhere in between is your on-premises cluster. So I'm just going to use the local cluster here, and so we've got the tray here, and we can display that. So this, I think it's a pretty nice, easy to use, effectively Explorer or like local cluster manager that we provide here. I think it's worth sort of just, we'll dig into sort of the main sort of sections of this in a second. So I've got my solution here. It's all ready to go. All I have to do is hit start, and the default configuration is to use this local cluster. And so hopefully in the output there, we can see it deploying, and this will sort of freeze it in time a little. But in this diagnostic events, so part of the code emitted diagnostic events, and you can sort of basically see it counting. So there we go, sort of, up to 15 already, one per second. So that's running. So let's have a look. What does that look like in Service Fabric? So it's sort of your typical Explorer, tree view on the left, details on the right. So we have our cluster here and provides the overview. So it sort of simulates 5 nodes. Everything's healthy. And we've got a dashboard here that shows the applications. And basically, we've got this one application running. And it's healthy. We'll have a look at upgrades in a few minutes' time. No upgrades running. Some more drill down here. I just wanted to introduce this. This will come in. We'll see this later, and it's sort of this concept of fault domains and upgrade domains. And I touched on this a couple of hours ago at my sort of IaaS, or Infrastructure as a Service session. And sort of this is a way where you have these multiple domains, fault or upgrade, and it's sort of a way so that you can have effectively multiple, like in some cases in Azure, it's in an availability set, multiple VMs, and you put them in different, and they're in different fault domains. So if there's sort of like the worst of all faults happens, then it only impacts the things in one fault domain. So part of the sort of the deployment and part of sort of the sort of management capabilities for Service Fabric, and then it's also analogous in Azure, is effectively the placement of the microservices or the placement of the VMs, because you want to place them so that if there is a particular fault, it's sort of isolated and has limited impact. And the same also goes for upgrades as well. We'll see the upgrade in particular. If you're performing an upgrade, it's not a big bang and you're updating everything at once, and even your service pauses for even a few minutes. You're going to upgrade, and actually even what we do, a strategy for the upgrade is you might just do a partial upgrade and then you spot a problem. So certainly what we do in a lot of our services is, we'll go through and we upgrade. You upgrade in stages, and so it's just little slices. So your system is continuously, obviously, available. But then if you notice something wrong after the first, you can either roll back or correct it without rolling out any further. So there's sort of both a fault case and an upgrade case when it sort of comes to sort of the robustness and reliability and availability. All right, so there's enough talking about that. So that's that. So we've got applications. So we can see application 3. This was application 3. We'll just dig into this. Various pieces of information we won't go into. But at the end of this, we get a node. So we're on node 2 here. So if we go to the nodes, say this simulates five nodes. We saw those split across the fault and upgrade domains. And there's no drill down here, but if I look at 2, as this indicates here, we can actually see my application. I can see it's a stateless 2 package, and there's some code. I know it says too much, no. And a particular instance of that. But basically, the bottom line, expose 3 and 4, I've just developed this one stateless service, and it's deployed to one node. So what happens if that node 2, something happens with it? There's a blip, goes away for whatever reason, might be a few seconds, might be a few minutes, might be a few days even. So what we can do is simulate that here, and we'll do a restart on that. So we get the confirmation, and let's restart. So this is quite nice as well, and you can refresh it up to every 2 seconds. Works well. So there's sort of 2 things to keep an eye on here. keep an eye on this left-hand side, and we'll keep an eye on this here, on the left-hand side here. So I'm going to click on there and then zoom in. So we can see here we've got, it's working, it got up to 256, then basically some stuff happened when I restarted that node. The node went away just for a few seconds. So obviously this is pretty low-level diagnostic information, but hopefully you can sort of pick up, and it's basically Service Fabric's basically saying, well, look, the node's gone away here, and I was running this service on here. I need to find somewhere else to run it. So it goes and finds, oh, look, I've got 4 other nodes to run this on, and goes and picks a node and will run it. But the particular thing about this case is obviously it's stateless. So hence my count was just sitting there in memory, hence my count has been reset. So obviously, as I said earlier, I sort of just wanted to stress, we can have a stateless service here that's working with the database or, even Azure Storage, Azure Tables, a NoSQL document DB, whatever it is, providing that persistence and the robustness for you. But in this case, within the stateless service, obviously, it's not providing that for us. That probably was. So if you remember, actually, it was node 2. So let's have a look here. We can see the other thing to notice is that this service now is running on node 4. So we can see in the Explorer here, and if we looked at it, I can do it again. If we go node 4, restart that. We'll sort of see it instead of focusing on the left-hand side. On the right-hand side, we should see, hey, look, the node's restarting. There might be some error information, and then just depends on the 2-second time, but we should see this then reset. There we go. It's sort of found out, and it's going to node. It's in the process of moving to node 2, and then within a few seconds, it's up and running on node 2. So this is another example of how you can, we'll talk about it a little more, but even take if you've got an investment in Azure at the moment, say on cloud services, or you've just got an existing XE that you want to run. Here's an example of, you can give it a set of nodes and how Service Fabric can start to manage this for you and, provide the robustness that you need, and effectively sort of the healing and the monitoring as well to detect something went wrong and then heal from it. So that's switched over. All right. That's actually the other thing. Sometimes some other error messages pop up, but there's because there's a number effectively of internal services that we're running on this as well. So again, they have to all be robust, and if any of the nodes go away, they have to maintain the state that they have and recover. So once I've just stopped that, and we can see this then starts to clear up, and this will come back. There we go. That's basically empty now. All right. So that was stateless. So just in terms of, it says Azure, it really applies to both Azure or on-premises. And sort of key thing here is, how do you support, we could have probably at least 3 nodes. We could have thousands of nodes here. So sort of what's the flow or the workflow here? So you could have some on-premises machines, could have some VMs on-premises or in Azure. Effectively, the group of these, they form your cluster, and Service Fabric is installed on them. And effectively, they form this ring. It's actually a ring topology. You're going to have your load balancer. So the way that actually even what Visual Studio is doing here and deploying this, it's going in to the cluster through the load balancer. But in our case, when you're deploying apps and management operations, it's going and talking to the Service Fabric microservices that are sitting there and performing those operations. And then we'll see towards the end a demo with a web component. If you've got effectively your customers, you've deployed your app, maybe you've got some web front end. Again, that comes in through the load balancer and finds the appropriate instance to point that load to. So Service Fabric obviously knows where their code lives, handles failures, restarts processes, provides that robustness. And there really isn't, I suppose there's none of these nodes that effectively are the master. Effectively the master node for each particular microservice can even change. I think as we saw when we restarted things. In one case, the master node for a particular service is 4, and then if something happens, then it could be 3. So there's another, we talked, there's stateless services and stateful, and that's sort of all wrapped up into these reliable services, and that's one part of the framework. And in VS, I think we saw that. We'll see it again in a second. There's another framework for actors, and these actors are sort of, it uses a virtual actor pattern. It's sort of very good for having lots and lots of objects, sort of single-threaded objects, and they can have their own state and so on. And you sort of see the use of those in a demo in a second. And it's sort of based off this, or implements this virtual actor pattern. So it's basically another choice that you have for some workloads. You can bring your own apps or develop, ASP.NET apps, and I think he even mentioned as well, you could even bring an executable, and you'll get some of the benefits, things like the monitoring and restart and so on, maybe some of the scale out with Service Fabric, but it's one of those things. The good thing is you can sort of stage your investments, and then maybe later on start moving to use the reliable services or the reliable actors, and really adopt some of the framework as well. Yeah. So I think we sort of really went through that. And the frameworks. I'll talk about on the reliable services, the data structures. It's best we'll just even, I'll show you that. Which will be now. So let's have a look at stateful service. So there'll be a lot in common here, but it's cool to sort of see the difference here. So we'll do a new project, do exactly the same. So there was the actor service I mentioned, the guest executable, and so on. And here we've just got our stateful service. So this will look pretty familiar, but there's a pretty obvious sort of key difference. So in the code it generates, again, got the same imports. This is all pretty similar in terms of the listeners and so on. And here's where the difference is. So we're in the main run async here. And it's really, this is sort of where I talk about, if you like, the first class sort of storage technology. So you can see that we've got the concept, we're going to increment the counter, we're going to do a plus value, it's called in this case. But we're doing this in the context of a transaction for the state manager. So the state manager, you can use to manage your state. And, this is all exposed via sort of, a dictionary. So you don't get, for example, so for this technology, if you need some big, almost the equivalent of like cross-table joins, or a whole bunch of indexing, or, there's definitely cases where you absolutely still need, the appropriate, say, SQL store, or even NoSQL store, or whatever. But certainly for, maybe some parts of your data, the sort of particularly, frequently used data, sort of what's in use at the moment, maybe where you'd want to cache as well, the stateful capabilities really can come in useful, and then the stuff that isn't as frequently updated and there isn't the load, then you could continue to use your other store. And this is a strategy again, I believe that I think Link used as well. They moved some of the data and did it in stages, and moved some of the very hot data into the storage here for Service Fabric. But basically, it's pretty straightforward. Within the context of a transaction, we're getting the counter, and then we're updating it, adding one, and then we're committing it. Other than that, basically, this is the same. If we go over here, this is basically empty now. So we'll deploy that. So we're registering it. Let me hop over here. We should see this start to deploy. And there's a key difference here we should notice pretty quickly. Okay, it's pretty much done. There we go. All right. So we've got our application, application 4. This is definitely what we're just running here. If we dig into this and we dig into the particular instance, now instead of one node, we have 3 nodes. And there's a primary and 2 secondaries. And so this is sort of some of the core secret sauce capabilities that Service Fabric provides. And this sort of follows, again, the same pattern. In the early days when we were working on SQL Azure or Azure SQL Database, it's how do you have these sort of commodity hardware with all the, they've got their own disks and everything, and you need multiple copies of the database. But how do you provide that availability and robustness? And so we have the ring topology here, and we've got basically 3 nodes, and we have a primary one for the data. But when that data is committed, it's always written to at least 2 places before that transaction returns. And then it could be written to the third one asynchronously. But the data is always obviously in more than one place at a time, but then there's always backups here that are available in case of an issue with the primary. So that's why we've got 3 here, because we've got state. So we can see that across the nodes as well. We've got the application here, here, and here, which is what this says. So and that's the same pattern, as I said, with the system. Some of these effectively system services, you could see them running on multiple nodes as well. So if I push that off to the side, let's have a look, and we can see our counters still working away there. So that's exactly the same as last time. So I think one of the sort of key things is what happens here if one of these nodes dies. So node 2 is actually the primary. Actually, well, we'll restart it. So we should see pretty similar to last time. You can see that said it was restarting it. We should see some change on here when this refreshes. There we go. And it says the node's down. And then it's come back again, and actually, but it actually has come back again, but now it's the secondary and not the primary. And let me go across. I can use the zoom it to freeze that, so we can see what happens here. This looks pretty different because it's noticed it's stopped, and it's registered a new service to keep it going, to keep sort of those three copies going, but my counter still hasn't reset. So this just seemed like a very easy to see sort of the differences between the 2 services, just because it's persisting that counter value even though the node has disappeared and it's failed over. So obviously it was robustly stored, and then it sort of failed over and the other nodes picked up. So it's a key difference between stateless and stateful. All right, so that'll clean up. So one of the capabilities we had in Azure, basically pretty much from day one, was like a cloud service, really a platform as a service offering. So this we had VMs, but we provided some higher level capabilities on top of those VMs and called them cloud services. And when we had to have some capabilities to allow you to increment the number of instances. There's some API around it. Has an instance gone away and so on there. But it really sort of supported the multi-tier design. You could have had the web applications, or basically you've got multiple roles within that. And even the cloud service model that you use to define your cloud services has one or more roles that you define. So which basically equates to these layers of your application. And these applications, obviously work with the various, they work with persistent storage or queues or the various caching or SQL and so on there. So with Service Fabric, that changes to we've seen this before, but just really to emphasize, you can take that and then you can break it up into sort of the microservices, and then use Service Fabric to manage that for you, and break up your roles or the layers or the tiers of your application, have them as the microservices, and have Service Fabric manage them for you. And obviously, initially, one way to break that up is, you would leverage the stateless. You'd still use the database. You'd still use the Redis cache or whatever that. So for small services, sometimes one of these previously and was asked, well, look, I've used cloud services. I've got an investment. It's relatively small. It's, I can manage it fine. It scales fine for what I need. Should I just proactively move? And the answer would be no. I mean, if it's managing, if it's fine for you and it's not an overhead for you, they'll work great and it's going to continue to work great. But maybe you were contemplating something new or you've got a big upgrade coming up, then definitely worth looking at the Service Fabric approach. So we're going to look at the rolling upgrade. So this is where you've got, you're basically your two tiers or your sort of two roles, and we sort of split it into these microservices. And you've got, you want to independently update one of these. What's this microservice is, it's managed. It might only be on some of the nodes. It might be on nodes with some of the other microservices. So how does a rolling upgrade work? And it sort of uses the concept I mentioned earlier about these upgrade domains. So this is where the service instances that are running are split up into these domains, and then as you upgrade, it only does one domain at a time, which basically maintains your availability for you. And while it does the upgrade as well, it's looking at the health, ensuring it's healthy, nothing's gone wrong before sort of continuing. One of the questions comes up sometimes is, well, does the Service Fabric or the framework sort of help you with the, that contract validation or validation that is sort of talked about earlier, the contract between the various microservices, and that's still something that you have to work with. You don't want to upgrade one of these, make a change to, the service package B in rather small font there. Make a change to that, and you break the contract. You may be effectively a breaking change. It is up to you to maintain that compatibility. All right, so let's try and we'll do an upgrade. So I've got a visual example for this. Okay, it looks like, so our cluster's cleaned up. We haven't got any applications on here. That's good. Minimize that. So I'm using, it's a solution it was developed called Visual Objects, and you'll see why in a minute. So this is one of the samples we publish, and they're sort of specifically designed to, I suppose it shows two things. If you're interested in the actor pattern, it actually uses actors. And we can sort of see here it uses the actor service and implements the iVisual Object Actor. So that's one thing, but it makes a particularly good demo for upgrades, because what you'll see is we have lots of objects, and they all have their sort of state, and they know where they are on the screen. We'll see that. And there's a number of those, and we want to sort of upgrade this, the particular the actor code here, and not the front end. And update that independently and see how the upgrade works. So specifically designed for that. So you can find this online if you want to run it when you get back. So the key thing here is, so we've got an application, we've got a move object. I won't go too much into that yet. We'll come back to that. I'm going to deploy this because I want to do an upgrade. I'm going to just deploy it slightly differently. I'm going to publish. So this is sort of almost like what was automated in the previous demos. I'm going to publish this. It's going to go to the local cluster. I'm not going to upgrade, and I'm just going to show you. So for the various packages that we have, actually, let me split that out. There's there's a versioning. So we can see we're starting from our initial version here, and the sort of component and the configuration, everything's basically version 1.0.0. So effectively, we're going to publish this for the first time. So while that's publishing, so this is sort of, there's two parts to this. Let me go in on the right-hand side here. We've got this actor service, and we'll see what the individual actors are doing here. But then there's a web service. There's a front end to this that's exposed via a web service. There's a web UI, so we'll see that. So and then there's a common solution here. But we're going to upgrade the actor service independently. So that's deployed. Looks like that's on, it's deploying. The state associated here, and these actors, there's state associated with them, so they are partitioned across the 5 nodes that I have. And I think so. Actually, so then there's 5 upgrade domains. So basically, one node effectively will get upgraded at a time. All right. So I think that's deployed. So we can see we've got 2 here on the applications. We've got sort of 2 services, the actor and the web. So let's have a look at that web. And it's exposed via this. So it's exposed on localhost with this port. And there we go. So basically, we just got bouncing triangles leaving a trail. And that's all, basically each one of these is the actor. And if we go into here, in the move object, we are moving the object, but when we're moving it, this sort of particular thing here, we are moving it, but then there's sort of like a false there's a Boolean associated with this, and this is sort of a rotation. So you're saying, hey, move this thing, but don't rotate it while it's moving. And now you can see here what we're going to do is we're going to change this. So you can even see in the background here these things, they're not rotating, they're just moving along. So let's upgrade this, and we've decided we really actually do want rotating as well as moving. We can simply do that. Let's build. And then we're going to publish. So that just built we built the actor. Now what we're going to do here is got exactly the same dialogue here, and we're going to say upgrade this time, and we're going to update the version. So the way that we can do this is to say, look, the only thing that we're changing here is the code for this actor package, and we'll change that to 2. So overall it changes to 2, but the web service remains unchanged, and save that. And we're going to and we take the upgrade, so we're going to upgrade the application and then publish that. So we should see a difference both here in the output window, and we'll see a difference in the cluster manager in a second. Let me go back here. We'll leave those guys running away. Let me go back up to the cluster. Hopefully we can see here, so it's doing an upgrade. And then here, we've got an upgrade in progress. So if I select that, let me zoom in here. So we can see that we're upgrading, and it's doing a rolling upgrade, and it's going to do a rolling upgrade by upgrade domain. And we've got effectively 5 of them here, 0 to 4. And that upgrade is in progress. So while that is in progress, it looks like it's done 0. Let's sort of shift back here. So if you can actually see, as it's going, obviously this guy was in the first upgrade domain. And as we go, we'll see, the web's still available, everything's sort of still running, and then just for the time that the particular part node, so these are spread across the partitions. The partitions are on each of the nodes. So there's a slight pause as that node upgrades. But sort of the key thing is the web service is constantly available. All the other partitions or the upgrade domains are permanently available. And then in the end, it looks like that's finished. It looks like everything's rotating. No, it is. It says it hasn't quite finished. There might be some there. Oh, maybe this it's a 2-second thing. Oh, there we go. I just maybe caught the wrong end of the 2 seconds there. So we can see the upgrade is finished now, and the actor is at 2, which I changed it to, but the web is at 1. So that's sort of the key thing, and you can go back and forth all the time or stop them moving and so on. But hopefully this sort of illustrated sort of a couple of the sort of the key concepts in terms of, well, we sort of did have state here that was maintained. We had the sort of these actors, which we've effectively scaled out amongst many nodes and spread out across these upgrade domains, so that then when we do the upgrade, we've sort of maintained overall availability of this application, and then just done each upgrade domain as we go one at a time until they're finished. So hopefully that's sort of fairly representative and sort of gives you an idea anyway on the upgrade process. All right, we'll shut him down. So when it comes to the service fabric, I was sort of where I'm going to just finish off here with a few references. I've got to find out tonight. I'm going to try and find out even during the Ask the Experts session, but I'm hoping you guys get these decks to download, because there's some really good useful links here in terms of there's some videos. Obviously, we've got a number of sort of the external customers. I think Jason actually this morning talked about TalkTalk, so to speak. Mentioned maybe some of those other guys. And there's some great case studies as well, and the blog, and some resources. Where do you go from here? So hopefully you guys can get the decks with the links. So that's all I had on Service Fabric, and then just in the last few minutes, I just want to sort of touch a little on containers. And I don't know if anyone's sort of really looking at containers that are pretty hot at the moment in terms of sort of ways to like virtualize your applications. And actually, I was just watching the other week a video with Mark Russinovich on, and he sort of really talked about the relationship of virtual machines and containers, which I thought was pretty good. And sort of really, I think virtual machines, it's all about virtualizing the hardware and the servers. So, we sort of provide those layers with the, obviously on the bare metal, there's some sort of host OS, and then, a hypervisor, something to manage the virtualization. But then you've got these guest OSs. And this is sort of really meant to show the proportions that an OS can be pretty big. And on top of that, binaries and libraries, and then your application. Maybe there's even multiple copies of your application. But obviously, huge value with virtualization over running on bare metal, and lots of flexibility sort of provides you there. But then with containers, and I sort of picked the Docker here, you're sort of really almost like virtualizing the OS, really. And effectively, sort of the container really is more of a zip. And you can sort of really hierarchical as well. So effectively, you sort of virtualize the OS, and you haven't got multiple copies of that. And then you can sort of build deltas up in terms of changes to the OS, zip for that, and then an incremental container image maybe for your application, maybe the binaries and libraries, and then even an incremental container image for the particular applications. So really talk about virtualizing the OS, and because you sort of got, haven't got the multiple copies of the OS, you should be able to, more tightly pack your applications. You've also obviously got the capabilities in terms of you have a lot more flexibility and responsiveness around starting up and shutting down. And this is sort of really plays, in general to, moving to the cloud and being elastic and so on. And, you've got that really enable that ability sort of to quickly deploy the applications, containerized applications, tear them down, deploy them, scale them, and so on, and really sort of be elastic. In Azure, I think it appeared maybe in preview early last year or middle of last year, and then we've GA'd it toward last quarter of last year. So we now have the Azure Container Service. So really our goals with the container service was to really support the various, we support the various sort of container managers and sort of containers in general and the open source frameworks and capabilities that were available, but really sort of take away the complexity around sort of configuration, deployment, how you sort of set these up, how you set them up on different numbers of VMs and so on. I think really when you need to sort of deploy these things, you can end up with lots and lots of configuration that needs to be determined, and it can be quite an effort to sort of set up effectively a cluster with containers. So as we'll see, we'll see what's involved in creating a cluster with a container service. Sort of the real goal is hopefully just with a few clicks and really simplified configuration, you can deploy containers. And I think the other thing is, we want to support exactly what's out there. We want to support the container managers in terms of like Kubernetes or Mesos or DCOS or whatever. We're all about making what the community has produced or various people have produced and what is out there and popular and what you might be using, and give you that choice and allow you to use that, but make it super easy to deploy and easy to manage within Azure. So yeah, I think the last point there is sort of interesting. We've got this enterprise grade infrastructure, all the things we talked about in terms of trust, in terms of sort of the trust and the compliance and the scale and so on. We've got this enterprise grade infrastructure, and then you can make it easy to deploy all these OSS open source capabilities on it. So what's involved in creating basically a cluster? This is time for the portal, Azure portal. All right, so we start at azure.com, we'll go to the portal. So those that saw an earlier session I did on IaaS, so I've got my Tech Summit dashboard here. I've got the list of services I frequently use on the left here, and near the top, I've got container services. So we'll have a look at this guy later. I've pre-created one just so we don't have to wait the 5 to 10 minutes for it to get set up. So let's create a new one, and then we'll have a look at that one that's already been created. Oh yeah, I've got to do that. So we need a username. We do need a public key. Paste that there. This is my Azure subscription. Talked again earlier on about how your Azure account can have multiple subscriptions. I've got a few I'm going to deploy to this one. I've got a resource group. So let's just say ACS Demo 1. So just as a reminder, or those that are new, a resource group is a set of Azure resources. And when we're creating this, we're creating a number of VMs. We're setting up the networking. We're setting up network rules. Associated with the VMs, the storage accounts, and so on there. So a resource group allows you to group a set of resources for an application normally. You group it into one, and then you can sort of makes it easier to manage as an overall group. Update it, delete it, whatever. I think you can even get some billing information on what's been consumed by all the resources in that resource group. And then my location. So that's the basics. This is where we get the choice. So, three main, we've got sort of the three well-known choices here, Swarm, Kubernetes, DCOS. I'm going to pick DCOS. That's just what I've got this set up for. So here I can pick my counts in terms of agents. So the number of things number of nodes in the cluster. Set that to 3 maybe. I can pick my VM size. This is just a 2-core machine. Probably can. Again, I showed this. Pick my sizes, get some recommended size. Let's go with this guy. Again, a 2-core machine. It's actually slightly faster. I've got a concept to master count. I can get sort of help here with the little hovers. And then a prefix. So that's a prefix. We'll see that in a second. I could enable diagnostics. It's like, OK there. Run some validation, just as it does with other templates or VMs or anything else. And then that started the deployment process. So again, there's the little notification window up here. I've got some notifications. And we can see, OK, this deployment has started and in progress. So this takes about maybe 10 minutes or so. What does that look like when it's finished? So I have, you saw earlier in the container service, so we can see, here we go, yeah. That was sort of the pre-created one. This is the one I just did, so that's deploying now. Let's click on the pre-created one. So pretty much very consistent with other capabilities in Azure. Get the overview here, or what we call the essentials. This is a key piece of information here. But information about the agents and the agent pool. This is this particular size, how many counts, I can update this. So various capabilities here. But it's all really about, say, this is all about managing the infrastructure required on which to deploy this container service and the container manager. So let me go back to the overview. So we can see we've basically got the name of this. Effectively, that's exposed, the endpoint to this cluster, and that's exposed here. So we need to connect to that. So the way we do that, it's all in the getting started documentation. So, we're not, there's nothing, this is all the existing, the open source stuff there, the manage it there, and it's exposing its sort of capabilities, DCOS, via, HTTPS. So the way I can actually tunnel through and get at that on the master node is on Windows, and on Windows here is use PuTTY. So basically what we're going to do here is set up an SSH tunnel. When I set that up, I had to put in a public SSH key, and obviously that's required for the, for the containers. So what we want to do to be able to see this here and effectively tunnel through to like the master VM and the service running on there is I would need to set up a SSH tunnel, and I can use PuTTY to do that. So let me load in the configuration. I know this is, I'll zoom in here. So this is exposed. So this host name that you can see here equates to, there we go, on the left-hand side. So this is sort of tunneling through, setting up an SSH tunnel through to that master node. So I've loaded that. I can open that. I need to type in the passphrase. So that should be me, and that should be my tunnel. So now, actually, let me go back. Oh, I can't do that. So that's tunneled, and it's set up so localhost port 80 will go through to the master node. So if I go to the browser, localhost, there we go. So we can see there the dashboard here. So I haven't got anything running on it. So it says there's I think there's, the master node and then 5 of these nodes, so there's 6 nodes in total. There shouldn't be anything running on it, no jobs, and so on. So really just the point of this demo was you see, what was there, literally 4 steps there and a few minutes, type in some configuration, and then it's probably still going, in a few more minutes I will have the cluster. And this is all sort of it's all the open source stuff. We're not reinventing the wheel. You can use exactly the same tools, technologies, and so on, supported by the community and available by the community. But we're just really making it super easy for you to deploy and manage on enterprise-grade Azure and infrastructure. So that's where I'm going to stop on ACS. As I said, tomorrow there's a deep dive into ACS. So if you really want to get it in containers, please attend that. It should be good. So that's it. We're out of time. Thank you so much for your time. That was great. Thank you. I'm going to stick around for questions, and I'm in the Ask the Experts as well. So anything Azure, feel free to come down. I think there's appetizers, might be some beer. I'd be pretty sure there'd be some beer between 6 and 7 o'clock.